Welcome to Module 7 of the Airline Engineering Supply Chain Mastery course. In this module, we delve into the concept of Integrated Business Planning, IBP, and its application within the airline engineering supply chain. This session will be divided into logical segments covering foundational concepts, frameworks, and real-life examples to illustrate how IBP ensures cross-functional alignment and operational excellence. Integrated business planning is a holistic approach that aligns strategic, operational, and financial planning across an organization. In aviation, IBP integrates engineering, maintenance, finance, operations, procurement, and commercial functions to deliver sustainable value. It extends beyond traditional S&OP by including financial and strategic dimensions. Example: Qatar Airways implemented an IBP model that links heavy maintenance planning with fleet availability targets, spare part forecasting, and financial budgets. This synchronization improved AOG rates by 20% over 12 months. Product and portfolio review, life cycle planning of aircraft, engines, and major components. Measures include aircraft availability rate, component pool utilization, on-time phase-in/phase-out of aircraft or major mods. Life cycle cost per fleet type, reliability KPIs by component and ATA chapter. Demand planning, anticipating future maintenance demand based on flying hours, cycles, and reliability trends. Measures include forecast accuracy for maintenance events, part demand, and AOG incident forecast variance. Line maintenance man-hour, forecast accuracy, and hangar slot utilization forecast accuracy. Supply planning, planning for tooling, spares, hangar slots, and manpower. Ensuring material, manpower repair, and logistical readiness to meet demand. Measures include spare parts availability rate, line maintenance fill rate, and repair turnaround time, supplier performance, inventory turns, and deferred defect clearance rate. Financial alignment, matching budgets with operational requirements, scenario modeling for disruptions. Measures include maintenance cost forecast accuracy, material spend forecast accuracy, and service level risk index. Plan versus capacity alignment, index and repair capacity risk. Executive review, monthly reviews involving engineering heads, finance, and COO to ensure alignment. Focus, escalations, trade-off decisions, financial and operational commitment. Measures include AOG rate versus target, budget versus actuals, and high-risk rotable coverage. Operational disruption cost avoided via IBP and decision velocity. Example: Lufthansa Technik's predictive maintenance demand planning reduced excess inventory by 30% while maintaining service level KPIs. A monthly IBP cycle typically involves Week 1, data collection and reconciliation from engineering and maintenance systems. Week 2, demand forecasting review with planning teams. Week 3, supply review including vendor commitments and resource planning. Week 4, executive review with course correction decisions. This cadence ensures ongoing feedback loops and course corrections. Example: JetBlue's engineering division adopted this cadence using Power BI dashboards linked to their AMOS system, resulting in more agile parts procurement and reduced vendor escalations. True IBP success in engineering supply chains requires breaking down silos. Engineering collaborates with procurement on LTAs and rotable pool needs. Maintenance teams share reliability trends with finance for budgeting. Finance builds dynamic forecasting models with scenario stress testing. Example: Emirates integrated engineering, supply chain, and finance dashboards using SAP integrated business planning. As a result, they reduced aircraft ground time for heavy checks by 15%. Modern IBP depends on robust digital tools, ERP systems, SAP IBP, Oracle Cloud M and E systems, AMOS, Trax, Rusada, analytics, Power BI, Tableau, predictive models, AI ML tools using flight data and sensor inputs. Example: Delta Airlines uses AI-powered models to forecast part failure probabilities and integrates these forecasts into procurement planning. Organizations progress through IBP maturity stages. Stage 1 functional planning, silos, manual spreadsheets. Stage 2, cross-functional S&OP, coordinated but limited integration. Stage 3, IBP, strategic, financial, and operational alignment. Stage 4, dynamic, AI-enabled IBP. Real-time predictive scenario-driven implementation requires change management, executive sponsorship, process standardization, data governance. Final example, Qantas' transformation from S&OP to IBP involved a 3-year roadmap with phased rollout across engineering, commercial and finance, improving their engine pool utilization by 18%. IBP is not just a planning process. It's a strategic capability that enables airlines to balance service, cost and risk across a complex engineering supply chain. In our next module, we will explore digital transformation and how it accelerates IBP maturity and resilience.